You hear me? Probably don't even need it, hopefully. I'm loud enough. So my name's Tim Sanage. I'm a senior security partner manager with AWS, so I represent quite a few security partners within our ecosystem and so forth. And then I also do quite a bit in security compliance, as was my previous role within AWS, so I work quite a bit with our security partners. So therefore, we got a really cool opportunity to hear from three of our security partners, their different takes on cloud security. And so we're going to kind of run this with 15-minute intervals for each one of the organizations, and then if time allows, we'll have questions at the end of each one of the sessions, but then we'll also have some questions at the end if we have enough time. So with that, I want to start out and get Nikolai up here.
Thank you. Can you hear me okay? Yeah. Great. So I'm Nikola Božinović. I'm the founder and CEO of Frame. And I'm going to talk today about cloud security and the end of the desktop. And we all know security is of uttermost importance. Attacks happen every day, millions of them. And we're going to hear later today how firewalls can help and how data analytics can help. But I'm going to talk about something that I'm sure it's in the heart of every IT organization. It's the desktop and the endpoint that is going through a massive transformation. Everybody uses desktop applications, thousands of them or hundreds of thousands of them, and they're not going away, even with addition of great web services that we're getting from the cloud. So the key challenge is, how do you, in this new environment, with the cloud at the heart of things, how do you manage and secure your IT environment? And things used to be really simple. If you remember 10 years ago, even, everybody had a computer. There were no tablets or mobile phones. There was a phone on your desk, but you used it really to make phone calls. And there was no work from home or work from travel, God forbid. So today, the world is a very different place. We have a variety of operating systems. We have a variety of form factors and devices. And this is making it incredibly complex and challenging to manage and also to secure. So the concept of virtualizing your desktop and virtualizing your endpoint has been around for a long time. How many of you have heard about VDI? Okay, how many of you are implementing VDI or are actively using VDI? So significantly fewer people. And we're going to talk about that thing exactly. So let me just, for those who are not familiar with VDI, talk about it for a second. So in a traditional physical desktop model, apps are running directly on a PC, just like in a photo that I showed. There is an office full of PCs. Apps are running right there. And things are relatively straightforward, but it's very painful to go and update and install all of those applications. In a new world with heterogeneous clients, things are even more complex. So this concept of virtual desktops and virtual applications really moves the workloads to the data center. So applications are not running on a PC anymore. They're running in a data center. And then you only stream pixels to your clients. And those could be desktops, laptops, phones, tablets, all of them. So there are two distinct advantages to this approach. One is applications run securely, and they never leave the data center, which is great. You really don't have anything on endpoints. And what they would say, you can't steal it if it's not there. It's really air-gapped from the end device. And then the second advantage is that because you're now streaming pixels and not running Windows applications, you can really do this for every device. So it can run on Windows, but also on Mac, also on Chromebook, also on tablet, and your phone. So this is a great, phenomenal concept. However, it comes with challenges the way it's been implemented in the world in the last 10 or 15 years. And there are a couple of, when people think about VDI, there are a couple of solutions. One is Citrix. The other one is VMware. And you can get it from Microsoft. But they all have a couple of significant inherent problems. So one is that all of those solutions are extremely complicated. It takes months, sometimes years, to get trained on them. They're very expensive because, after all, you have to get that data center in place, and it costs a lot of money. And even when all those things are put together, very rarely will people say, I really love how things run, because the protocols and the management console, that was all done 10 or 15 years ago when expectations were very different. So because of all of this, we have less than 5% of all desktops in the world that are today running in a virtual environment. And it's a multi-billion-dollar business for Citrix, VMware, and others, but it's less than 5% of the world is running that way. So we're here at AWS conference because we all agree that cloud changes everything. And it allows us, for our workloads, to skip entirely the data center and to go from PC to go to the cloud. But then the key question is, can we really rely on the same old legacy technologies, like Citrix, like VMware, to help us in the cloud? And the answer is, we have this great platform. And if we design this infrastructure and we continue to do business as usual, it will be an absolute waste of money. It's like designing the Autobahn with a horse and buggy. And those are not my words. Those are words of Lieutenant General Winston Stewart, who's the director of the DIA. So they have seen the future. And the future is not in the old school legacy VDI. So we believe that future is frame. And I'm going to tell you how we envision that future. So we build a platform that is cloud first, that is very secure, and it lets organizations, both commercial enterprises and then government enterprises, from state to local to federal government to intelligence community, to deliver amazing experiences to user on all connected devices. So as long as you're connected on whatever network you are, you're going to have a great experience. We provide that with a zero local footprint. You really don't have to install anything on your device. You open up a browser, you click on an icon that the administrator set up, and you can have right in your browser any Windows software that you need to use, starting from Office, going to Photoshop, going to AutoCAD, using line of business applications, GIS, literally anything. And we believe that this is ushering us into a new era of end-user computing. We started doing this 4 years ago. We were headquartered in San Mateo in California. And over the last 4 years, we gained trust from all top Windows ISVs and some major enterprises. Gartner recognized us as a cool vendor. So let me tell you about people who are using Frame today. From Adobe, using Frame to deliver Photoshop, InDesign, Illustrator, in commercial and educational sectors, to Autodesk, that moved all of their applications to Frame, and it's using them for product development, beta testing. And we have SolidWorks, Siemens, PTC moving their heavy-duty apps to the cloud and allowing millions of people who wouldn't have access to this because they don't have the right hardware or the management is very, very painful, to really reach a dramatically larger audience. And there is something very unique about this time, this year. If you remember how the world looked like in 2008, before Dropbox or Box and Google Drive and OneDrive, we all take for granted today. I mean, billions of people use those services today. And we had to live with FTP. And everybody hated it. It was awful. So we think that same thing is going to happen for VDI. It's going to go from I hate it, it's going to go to I really, really love it. And it's helping me run things better, run things more securely. And it's this momentum that we're getting not only from the cloud infrastructure getting in place, but obviously from getting better networks in place. We already moved so much data in the cloud. And it makes sense to move our apps and to have apps and data securely in the same data center. So this is the year where it starts to be possible to run things at hyperscale in the cloud. And opening an account on Frame and starting with Frame is not that different from starting with Dropbox. You can all try it at www.fra.me. So it's easy to remember, Frame with a dot before ME. And it works really, really simple. You can do this in under an hour, guaranteed. You figure out what are the applications that you want to deliver. I already mentioned some: Office, Photoshop, AutoCAD. You figure out where you want to run it. So if you're a school, you can run it in a public cloud. If you have ITAR requirements, you can run it on GovCloud. And if you're in the intelligence community, you'll be able to run this on C2S. Once you figured out where you want to run it, that's all configurable as a part of the system. You connect to your authentication system to know where your users are. They could be in Active Directory, or you might be using something like Okta or Ping or Azure AD. And then connect files, where, again, you can use existing cloud storage solutions from Dropbox, Box, OneDrive, Google Drive. And at the end of that hour, you're up and running. We take care of everything else. So no worries about the hypervisor and no worries about anything else. Going under the hood, Frame is incredibly flexible, incredibly configurable, and API-friendly system that lets you do advanced integrations with your workflows. If you have custom storage on S3, you can very easily bring those files and make them available from inside Frame. If you have your own authentication system, you can do that as well. And we rethought all the concepts in the VI, from the broker to the protocol to the storefront, and packaged it in a solution that is beautiful, that's very intuitive, and that all the people who maybe have heard about VDI but didn't have a budget or didn't have the time to go through the troubles of configuring it can use pretty much instantly. And we have interfaces for people who are operating this. So that's our super admin interface, where you are, let's say at the level of organization, you are assigning certain resources to your teams. Then each team can very easily install their own applications. So you could have one department versus other department using different apps and having different users. And finally, all users have to do is fire up a browser, click and run, with a great advantage that nothing is really ever downloaded to your local device. So if you have a computer, you lose it, no big deal. Nothing but pixels ever makes it to the endpoint. So with that, I want to just sum it up. How is Frame fundamentally different from VDI, and why it's going to bring us into the new day and age of application delivery? Well, we are cloud first and can run things on a web scale. Frame is programmable and has APIs for pretty much everything. Everything you see in your interface, you can drive through API as well. This is the first platform that optimizes infrastructure management as well. What that means is that with traditional VDI, you just fire it up for your peak usage, and it idles most of the time. Andy Jassy talked about it, how utilization across government data center was 7%. So you can save 90% or maybe even more by being smarter and using elasticity of the cloud. And what Frame does is when you're using the system, we fire up VMs that are needed. When you don't use the system, we shut them down. So you pay only for what you used. And finally, it's flexible, so it can mold into any number of workflows. So if you are having lightweight workflows versus design workloads versus simulation workloads, it can cover all of that. So with that, I want to invite you all to try Frame first. It's really simple. It starts by entering your email on our homepage, which is fra.me. And you can also reach out directly to us at info@Frame. Thank you very much.
All right, with that, we're going to bring up Matt from Palo Alto Networks.
Good afternoon, everyone. So if you've never had to put together a presentation for 10 minutes, you should try it. It's a good exercise. You don't know whether to cut down slides or start from scratch. I started from scratch. So Palo Alto Networks, for those who don't know who we are a firewall in AWS. The difference between our firewall and perhaps Checkpoint, Cisco, Juniper, Fortinet, or Barracuda is that we classify traffic based on the applications and not the protocol. So now you build policies based on those decisions, that information. So what I'm going to do today is talk to you a little bit about the 3 considerations that you should take into account when your boss says cloud first, right? When I was putting this together, I thought about this cloud first, right? Sounds so easy. Yeah, just go do the cloud, right? And I'm a do-it-yourselfer at home, and I made the connection. None of my projects ever go as planned. None of them are as easy as you might think. And I think that's probably what is going to happen when we go to the cloud first. So my focus will be on security. So the reality is when you move to the cloud, things will change and some things won't change. What does not change is the fact that is the attack lifecycle, right? Attackers don't care where your data is, right? They don't care whether it's in a server in a back room with the broom and the mop, or whether it's in Amazon. The cycle will be the same. The endpoint is compromised. They establish a foothold. Command and control occurs. They find the target. The target might be your user data, credit card data, intellectual property, blueprints. They might use resources to harvest Bitcoin. We heard about a customer who didn't lock down the AWS account, and it was used to harvest Bitcoin, which is basically consuming processing power, right? And so these are the things that you need to take into account, whether you're securing your physical network or whether you're securing the cloud. So you need to apply the same rigor, or more so, to your AWS efforts than you would in the network. So, oops, how about that? I'm going too fast. There we go. Sorry about that. Was I doing that, or was it automated? All right. So know and understand the 3 considerations. Know and understand the applications that are there. As I mentioned, we can give you that visibility into applications that does not really exist in the native AWS services. Adopt a prevention architecture is the second thing that you need to take into account, and I'll talk a little bit about that. And the third is strive for consistency. Many of you are already Palo Alto Networks customers. The functionality that I'll talk about today is exactly the same as what you have in your physical firewalls. So there is a great opportunity for consistency in security policy. And it can be centrally managed so that you have a group of policies for your physical firewall and a group of policies for your virtual. So reducing your threat, the first thing, visibility into the applications. Knowledge is power, right? So we complement security groups. One of the most common questions I get is, how do we work with, differentiate from security groups? Security groups is the Amazon native service that gives you visibility at the port level. We complement that by giving you visibility at the application level. So you open up port 80 and security groups, we can apply filters at the application level to allow just those applications, taking full advantage of the denial else premise that a firewall brings to the table. You can whitelist applications. So just as you would whitelist applications on your data center in your physical network, you can whitelist those applications in AWS. And then tie into Active Directory to grant access based on users. So you're reducing the exposure and reducing your threat footprint by reducing the applications. Segmentation. So segmentation, particularly when we look at what's happening in AWS and the projects that you're moving to AWS, they are typically data center oriented. So you want to be able to segment that environment, keeping the data separate from the applications, keeping your development team separate from perhaps the production team. So you can achieve a greater level of security and also use that for compliance purposes. The VM series, our product in AWS, utilizes what we call a zone-based architecture. So I can set up a security zone, and in that zone resides my data, the application data. In another zone would be the application itself. So by keeping those in separate zones, setting policies that allow and deny traffic in and out, you can achieve PCI compliance or other data separation compliance for regulations. Consistency, excuse me, consistency and automation. So consistency is very important, right? Because you want to have a consistent security posture from end to end. So even if you're not using Palo Alto networks in your physical network, you can use our product in AWS, make an IPsec VPN connection into that environment, and strive for some policy consistency end to end. Automation is particularly important as you move into the cloud. What we see happening is the cloud guys, the cloud teams tend to operate rapidly. That's the beauty of the cloud. Security teams operate with process control in mind. It's change control, right? So you've all had, I've heard numerous stories where the policies it takes 2 to 3 weeks, 2 to 3 days, a longer period of time to update the security policies than the development team or the cloud team wants to put up with. So there's this constant friction. With some automation features in the product, we can actually dynamically drive policy updates. So as your workloads change, expand, and contract in that security zone that I described, we can learn with that information by taking advantage of the AWS tagging capabilities and dynamically drive policies, security policies, so that they are updated automatically. So you can effectively eliminate the commit process that you are traditionally follow with a firewall. So you don't have to go that far, but that is the type of automation that we can bring to the table. A new feature we just released is bootstrapping, which also further automates the deployment of a firewall. So with an XML file, you can actually deploy a fully configured firewall so that you can scale up and scale down quickly with the identically configured firewall. So automation, very powerful within PAN-OS, our operating system. So the key takeaways, know what's happening in AWS, right? Knowledge of your applications, the content that's there is key to reducing that threat footprint. Segment and consider whitelisting to keep your applications and data separate. Better for security posture, helps you achieve compliance. And then policy consistency. The workload is going to be agnostic, right? If you use an IPsec VPN connection from your corporate to AWS, you can actually extend the the IP addresses from your corporate into AWS, which gives you a greater step towards policy consistency. I'd tell you to go by our booth, but I think the show floor is closed. But I'll be around here, and my colleagues who are in raise your hands. So look around if you have some questions. Afterwards, we don't have time, you can ask some questions. And I'm all done. How's that?
We'll bring up our last speaker, Michael. There you go.
Great, thank you. Great, is my microphone on? You guys can hear me okay? Great, so my name is Michael Schmidt, and I'm the founder and CTO of Newtonian, and we are an artificial intelligence company, and we work closely with DLT Solutions, who are we work with for all of our engagements on the public sector. So, I've been very fortunate since founding Newtonian, just in the past couple of years. Forbes and MIT have listed me as one of the foremost leaders in AI and data science. So I'd like to spend the next 10 minutes telling you guys a little bit of what the state of the art is in artificial intelligence and some applications that we see in cybersecurity and similar types of problems in Internet of Things. So one of the biggest problems, biggest challenges that we face over the next 5 to 10 years is basically being able to wrestle with the vast amount of data we collect today, right? And let's be honest, the type of data that we collect that's security related, IT related, sensor data, all this type of data we collect is not the prettiest data in the world. It's actually very noisy, it's ugly, it's hard to find the signal in the noise. And our means of actually tackling this problem today are incredibly difficult to scale, right? Imagine spending thousands of human hours just trying to find this pattern, the signal, the meaning in the noise. Which parts of the data are relevant? Which ones are important? Which ones are predictive? Which ones help us detect new patterns into the future? This is a problem that is extremely hard to do manually, but state-of-the-art of AI, we can solve these challenges. We can actually take raw data and find the meaning in this really noisy, chaotic data that we collect today. So that's what I'm going to tell you a little bit about today. And this has been the inspiration, the foundation of the AI that we use in Newtonian to help clients do this at scale in their businesses. So let me give you a quick overview of Newtonian, who we are, and our brief history. So like I said before, we're an artificial intelligence company, and it started basically back when I was in grad school. I wanted to help scientists scale with the complexity of the problems they face in physics, biology, and medicine. When I saw these people would basically spend the first couple of years of their programs designing experiments, collecting data, and then they'd spend the next 3 to 4 years in some cases basically retraining themselves in data science, math, and statistics. You take this deep domain expert and basically have them spend almost all of their time doing hardcore statistical modeling to decipher the data they were collecting. So that inspired me to focus on AI, machine learning that could help them decipher that data. What I wanted to do is help them go from data to the absolute best hypotheses on how that data works. So whatever they were studying, what were the variables that mattered? How do they appear to interact? And what is the structure of the problem? What is the formula? What are the rules, the patterns that exist in that data that you can rely on for prediction, for analysis, for control, for designing new experiments? Gaining insight into how something works. Going from a huge, wide-dimensional data down to, hey, here's the important parts of it, here's what to focus on. And that was a challenge that I focused on. It was very difficult to do, but eventually we had a breakthrough. And we published this in the Journal of Science. And what we were able to do is we were able to take physical systems, right? In the first time in history, we were able to teach an AI, a computer, to think like a scientist, think like a physicist. What we did is we took, in this example here, this is a special device called the double pendulum, and we had motion tracking cameras watch this thing. It would collect time series data, and it would produce this really crazy pattern. So this is an example of a chaotic system. And the data that it generates is almost indistinguishable from noise. So you could give that data to human experts, modelers, and they could spend years trying to figure out, hey, is this a real signal or is this just random noise? But to a computer, to the algorithms we were able to develop, to the AI, you can solve this problem almost instantaneously. So we could come back for the very first time with the characteristic equation that describes how this thing works. And this is the first breakthrough we had on being able to go from data to an explanation for here's the pattern, here's the rule that this thing always obeys. And even though this thing looks pretty complicated, this basically tells you everything you could ever want to know about this system. How it behaves, where it'll move in the future. All of its properties are captured by this. You could use it to detect new states and basically understand how it's put together, even though we never programmed into the computer anything about physics, anything about geometry. It was able to bootstrap up from raw time series data how things appear to interact. And if you think about the data we have in cybersecurity and Internet of Things, we really don't fully appreciate or understand all the moving parts, how they interact. What we can do, and what I'll talk about later, is how we can use this type of AI to determine how those parts actually interact without having to know the entire complex system ahead of time. Right, so that's the power of AI, and that's what you can do today, and which I'll tell you a little bit more about. So what's the big idea with Newtonian? So we're able to basically take raw data. We connect it to whatever data source, data feeds you have, right? And then we can build and find the best way to model the system, right? And then we can actually explain what those patterns mean. So an equation to me, a formula or a model derived from a data set tells you a lot of information. We can now automate the interpretation of that, the physical meaning that this pattern represents. So the first time, not only can we find the patterns, we can actually explain them back to you with AI. And then you can take these patterns and use them for almost anything, from predicting new alerts into the future, right? Programming in rules, detecting the normal behavior of a system and then deviations from that. All the consistency, the general patterns and trends that exist that are inherent intrinsically in the systems you operate on, you can capture and then use almost anywhere. So real world data that we tend to work with is really not as simple as previously has been possible. Most data sets that we work with today have thousands of signals. In fact, we have some customers we work with have tens of thousands of different things that are interacting, right? And like one of our customers, for example, someone's career is probably spent on the latency for this particular endpoint. If that server goes down, they want to know why, how that happens, how to predict it, what causes that to happen or not. We'll let them basically test and monitor all of these at scale so that AI can predicting how these things behave, when they'll fail, and what to do about it ahead of time, right? And imagine trying to do all this by hand. You would spend, as a data scientist, years looking at all these sort of signals. It just wouldn't be possible to do this with the current tools we have today. You need to be able to use automation to decipher this complex of a system at this sort of scale. And that's what we focused on with our AI. So what I showed you before is really able to take that raw data, you throw it to algorithms, to AI, it can come back with the fundamental properties, how the system behaves, what it'll behave like in the future, what to do about it. The challenge with that is that there's no free lunch, right? So by applying these and deploying these sorts of AI solutions, we in particular use a large amount of computational effort. So part of the reason we're here today is for our services that we provide in the cloud, we spin up a huge amount of CPU compute. We're extremely CPU intensive, but allows you to discover things you would never be able to find by hand. Correlate things you would never find through any other type of analysis. We can find all these sorts of things using AI. But we basically are able to scale almost linearly due to the nature of how these systems run. To analyze increasingly complex systems, all we do is spin up more and more compute. And it lets you unlock incredible amounts of value in data that you probably haven't been able to access before. So I often get asked, what's one of the first applications of this technology that do we apply to right after we did some of the scientific applications, this sort of thing? So of course we use it to gamble, right? So we just did this just a few weeks ago. We applied this to the Kentucky Derby. So for fun, we wanted to predict which horses would win the race. And we happen to have a customer that they use our AI technology for evaluating horses, right? Race horses, this sort of thing. So they said, hey, you should really, throw your hat in the ring, try this out, try making some money off of the technology you have. So we threw this in there. Like none of us at the company know anything about horse racing at all, but we had the data. We figured we'd go and give it a shot. So we took the data over the past 10 years of the races, the Kentucky Derby, and we decided to predict what's the position of a horse going to be relative to other horses in that field. And incredibly, we had 4 out of the 5 correct. So we won the superfecta bet, and I remember getting texts from our SE who helped run this project, who made like thousands of dollars off of like a $10 bet or something insane like that. So it shows you don't have to know everything about horse racing up front. You don't have to be an incredible expert. These patterns exist in the data you have. You just need the right applications of that data to unlock some of these patterns, right? So we'll be publishing, I think, every year now. People really want to know what we're predicting. So, email me next year if you guys want to put down a bit. How do we apply this to cybersecurity data? We see Eureka sitting on top of something like a SIEM, right? We're not trying to be the all-purpose aggregation tool for these things. We can take in that same type of data after it's been aggregated, connected, and provide incredible insights into that data. How do you define new alerts? How do you forecast new approaches? These are things that we can now automate directly from that data to really unlock the power and blow out the predictive accuracy that you have by applying computational effort to the problems. And I want to talk about one particular project that we worked on very, very recently on industrial control systems, where This is a challenge of for a physical security system. You can monitor all kinds of things like what's the voltage in a line, what's the current that's going through certain systems, what's the heat in the room, these sorts of things. And you could take a whole bunch of instances here. So I think here we're plotting something like the impedance on a particular power line, and this varies naturally over time. Some of these events are intrusions into the system. Some are actually regular maintenance that's going on throughout the facility. So how do you actually differentiate regular events versus some of these intrusions? Right? So we could throw this type of data at Eureka, our software, and see what happens. So Eureka, if you throw this type of data on it, it will actually come back with a model that will precisely describe, here's the relationship that's going on. Right? I'm showing you very, very detailed here. This breaks down into, hey, it's the current on the line, it's a voltage phase angle that turns out to be really important. And these combinations of things are what describes and differentiates a natural maintenance event for this facility versus a hostile intrusion, an unusual event. And look how interesting and complicated this is. You wouldn't be able to find this sort of pattern by hand. You'd have to know of the hundreds of different things you're monitoring or sensing in this larger system, the security system, which of these actually interact? How do I best combine those variables to actually build and determine what the rule is for something that is not expected? Right? But this is the type of thing that AI, Eureka, the things they're working on, could automatically pull out of the data. Right? So before I wrap up, I wanted to reemphasize that, hey, this new type of machine intelligence and AI can automatically extract this meaning from the data. A lot of early adapters are already using this, and you don't need to be the world's top data scientists to actually apply, deploy, and use this technology now. All these sorts of preparatory things can easily be tried out, automated. So I really encourage you to go out and try this sort of new technology, any type of systems you have. Thank you very much.
Questions for any or all? If you guys don't mind, we'll have you guys stay up here, and I'll even grab another chair. So any questions for any of our speakers?
I actually have a question. What are the advantages of Frame over Amazon Workspaces?
It's a great question. So I think I hit on a couple of points. I'll start with elasticity. Amazon Workspaces is a persistent desktop for a user, which means you fire it up, it's up 24/7, and rarely you use it 24/7. And unlike that, Frame gives you full flexibility to scale things up and down as things are being used. So kind of that's number one. Number two is we developed our own protocol. It is based on H.264. It allows you a lot bigger flexibility in delivering things under different scenarios. Unlike us, Amazon licensed their protocol from a company called Teradici. And it's a good protocol, but built for a different day and age. I mean, it was built about 10 years ago with a different constraint in mind. And we love Amazon. We run lots of things on Amazon. I mean, another advantage of Frame is that you can also run it on using different cloud infrastructures as well. So those are a couple of.
Gotcha. And what's it running on top of? So I know that Amazon Workspaces, the Windows 7 experience over 2008 Server R2, but what's the...
Yeah, so we run, you can choose, in fact, that's another flexibility. Most of our workloads are Windows Server 2012 R2. You can also go with Windows Server 2012, Windows Server 2008. There are circumstances under which you can bring your desktop OS, but that's in-depth details with Microsoft licensing and lack of SPLA today, Service Provider License Agreement. But it's entirely possible to do that as well with a little bit of trickery.
Gotcha. And then I guess last question, what's the cost structure like?
You have details on our website. And it starts for different products. I mean, Frame for Business and then Frame for Enterprise. It starts at $12.99 per user per month. That's significantly cheaper than Workspaces.
Thank you.
Yeah.
Will we get to a point when we can predict sports to the point that it's not fun to watch?
Ask Warriors.
The question was, will we ever get to the point where we can predict things where it's no longer exciting to watch sports, right? So, one thing I glossed over is there's always some stochastic elements to certain problems. So, I remember we did a challenge with the NCAA. We were trying to predict a couple years ago when Warren Buffett had the $1 billion challenge to try to predict the entire NCAA bracket. And we can get up to about 80% accuracy of predicting the outcomes of games, but there's still that 20% that just is not in the data, right? There's some variation that we can't control, but we can get the very best possible with the data you have. So I think we ended up calculating, based on 8%, our odds of winning the $1 billion were like 1 in a million or so. So it's still worth the expected return to try that sort of problem, given the high stakes. But no one was able to win it. But there's always that stochastic element to it. And there's things we're not always going to have total information about the system. In fact, a lot of people ask, are we going to start replacing people's jobs? I think it's only going to accelerate the number of things we do. And the game's going to change from, can I process this information, to let's throw as much information in there as possible so we're capturing some of these things.
So have you pointed your AI engine at a repository from Splunk or ArcSight, something like that, and generated, like an advanced, taking away the SOC's job, their security operations center, where your AI is saying that's an attack, you can ignore this?
So we will often pull from databases or aggregators such as Splunk to consume that type of information. But I would never claim to completely replace that sort of job, right? I think to solve a problem, you need only half the information really exists in the data. The other part is in the domain expertise that someone's bringing to the problem. So even though we can incredibly accelerate and do things at a scale you wouldn't be able to do by hand, you still need that person to provide the context, how to actually solve the problem, the right information, how to frame the problem to start, that lets you be able to do that, that unlocks that. So it's really sort of a combination of traditional roles with this more powerful analysis and consumption of the data you already have.
I have a question to all three of you here, because this is about security or public sector. So you all bring methodologies and applied mathematics, AI, and you're bringing an option VDI, and you're bringing a new approach to firewall. So we're in the government. Policy is everything. Trouble with security policy, getting things to be agile, getting to run performance and cost the way we need it to run, is getting us to a DevSecOps type of environment. How do you all three see yourselves impacting that? Because it's interesting to hear the products you're talking about, but we're in the public sector. If we can't adopt these agile, high-performance, low-cost environments, if everything that you're bringing to the table can't change risk management. Because even with AI, we know that even the 20% you're talking about, or any of these products you're talking about, they got to be able to move the ball forward with the CISOs and say we could do better risk management so we can start adopting cloud. I mean, how do you guys see yourself impacting that? Because we're in the public sector.
You want to go first?
I mean,
Sure.
I'll start from.
I think there's a little bit from each one of us,
Yeah,
right? Yeah. No, go ahead. Yeah.
Yeah, I mean, when it comes to Frame, I'll give you a very short story of how Frame started. And 4 years ago, I was the CTO of a software company, founder CTO, and we delivered a software solution. It was a high-end video processing application for real-time drone video analysis. And we were getting into a lot of deployments inside the government and inside DoD. And the big problem was that bringing our solution and bringing any other solution into a very closed environment, installing it on a physical machine, takes forever. It's a big security risk. When you can run it in a data center, stream it to a local computer with no local footprint, it's a big security improvement. And it accelerates adoption by many, many quarters. And what we are doing today, and that's how Frame really started, by building a platform, a VDI platform, to deliver applications into secure environments. And we have a number of customers in the public sector today, starting from education, going to federal government, and going all the way to intelligence community. And we are working closely with partners like Amazon to make those solutions widely available to customers. And I think all solutions, they work together. I mean, the great thing about security is you can have multiple lines of defense. And in our case, it's air gapping where the application runs from where it's consumed, and which allows you to have a much tighter security model.
From our perspective, we're working closely with DISA and AWS on a project called the Secure Cloud Computing Architecture that we'll see. They're going to talk a little bit about it this afternoon at 4, and it'll be available as a quick start guide from Amazon in later this year. And then we're also working on, we're recently made available in GovCloud. So there is that. Now you can deploy it in the commercial region of GovCloud as well as, commercial region of AWS, as well as GovCloud. And we're going through the requirements process for C2S, for the intelligence community. So there's and then just going through the rest of making sure that we are fulfill the necessary certifications, I think, is an important piece to allowing you to removing those obstacles that you might face in the public sector.
I would just add to that I think, from my perspective, everything I've seen, there are huge low-hanging fruit applications. We're really sort of beginning. There's so much that has not been optimized that it's worthwhile doing these things, and it's easier than ever to do it. Like we have one customer that went from capturing, I think, like 60% of events that were happening, and just by throwing in more information, by throwing into our services, Eureka, we went up to about 96% accuracy of capturing these events. That was just a massive, massive change. That would make like millions of dollars per week for these people to be able to capture that sort of thing. And this is sort of typical what we see when we typically go in and start working with someone, that it's worthwhile to actually looking at problems, even if you think they've been optimized before. You should do this because there's going to be huge impacts into applying your data in smarter ways. And I think services like AWS allow it to be easier than it's ever been before. You don't have to have a huge data center already pre-installed or set up. You can really spin up cloud compute on demand and try these things out very, very easily with the data you already have. So I would really encourage you to do more there, not hesitate.
Just one last question here. This young lady here had a question, and then we'll wrap it up.
More about the AI. I have a friend who owns an energy company, energy trading company, and lots of data, lots and lots of data. I was just wondering about, he's processing it on his home computer, but it's too much data to be compiled efficiently, and he hasn't moved to the cloud yet. And I'm wondering if that sounds like a great solution where the AI data is processed in the cloud and the results just come down to his client. Is that the way it is? And the safety of doing that. That's just kind of, I was wondering if there's a trial of your product or a way to discuss it.
Yeah, absolutely. So if that's we should talk about the use case afterward. But the bigger picture here is how do you scale with the data and the complexity of the problem? And I think what AI allows you to do that is just use more computational effort, right? So the idea is, we often talk about this concept of a virtual data scientist, right? Where you can plug in more compute and be able to do more with the data you have. So that's the dream. That's what AI. That's what we're working towards, is being able to use more information more efficiently. And the cloud lets you scale up the complexity just by adding more compute. So absolutely, if the data is getting too gnarly or things like this.
Cornell, I saw that you work with statistical, stochastical, all that stuff, so modeling. So that's why it was my thought.
Yeah, absolutely. Let's talk more about that afterward.
All right. Well, I'd like to thank the 3 speakers today. So I'm sure if you have one-off questions or whatever, if you want to get business cards or so forth, I'm sure the speakers will be available. So thank you, everybody, for attending. Appreciate it.
Thank you very much.